Inequalities. Some definitions first. Inequality is a statement that compares two expressions. The solution to the inequality is any number that makes the inequality true. Solutions for inequalities will be more than just one number. It'll be many numbers that makes the inequality statement true. An inequality uses these symbols. To represent greater than, this is the symbol we'll use. To represent less than, here's what the symbol looks like. Greater than or equal to will be the greater than symbol with a line underneath it to represent the equals part of the greater than or equal to. And then the less than or equal to. We'll have a less than symbol with the equal sign underneath it. Vic number 1, very important concept. Since the solution of an inequality is not just one number, when graphing inequalities, you can use the graph to indicate all the solutions. So we're going to be using an open dot when we represent inequalities that are less than or greater than. We will be using a closed dot or a closed circle for any less than or equal to or greater than or equal to statements. First, let's identify some solutions to inequalities. Is each number a solution of x is less than or equal to 7? And you have some options here. We have a, which is the number 9. So we are going to test to see if 9 is a solution to x is less than or equal to 7. So what we do is we plug in 9 for where x was. And we look at this statement and we ask ourselves, is that true? Is 9 less than or equal to 7? No, that is not true. So 9 is not a solution. Let's look at the number -1. We're going to plug in -1 where x was, and then we examine this scenario. -1, is that less than or equal to 7? Well, yes, it is. So that is a true statement. That is a solution. Letter C, 7. Let's plug in 7 where x was. This statement reads, 7 is less than or equal to 7. That is actually a true statement because 7 is equal to 7. This stands for less than or equal to. So that is a true statement. 7 will be a solution to this inequality. Is each number a solution of 3 plus x is greater than 5? So for A, we're plugging in the number 0 for x. So I rewrite the problem, 3 plus 0 is greater than 5, and I simplify. 3 plus 0 is 3, and then I look at this and I ask myself, is 3 greater than 5? No, it's not. So the number 0 is not a solution. 2. Is 2 a solution to the inequality 3 plus x is greater than 5? Well, let's see. I plug in 2 where x was. 3 plus 2, that's 5. So is 5 greater than 5? No, 5 is not greater than 5. It does not have that or equal to portion underneath it. So I'm going to say this is not a true statement. And then the last one, 8. If I plug in 8 where x was, and I simplify, 3 plus 8 is 11. 11 is greater than 5, so 8 is a solution to this inequality. Now on to graphing inequalities. If you have a problem that says graph c is greater than -2, there are a couple things we need to identify first. We need to identify if we're going to be writing an open circle or a closed circle on our number line, because we're graphing these on a number line. So it is a greater than symbol, so that means I'm going to have an open circle. Well, where am I going to put my open circle? I'm going to put my open circle on the number -2. And then there's a shading portion of our graph. We are going to shade all the solutions that make this inequality true. So if we look at my number line, I'm counting by 2s. I've got some negatives numbers, I've got 0, and I've got some positive numbers. Well, I'm going to draw my open circle on the number -2, but I'm shading, or I'm drawing an arrow that will show you all of the solutions that could be a possible answer. So -2 is a possible answer. -2 is not a possible answer, and that's why I leave it an open circle. That represents -2 is not a solution here, because it has to be greater than -2, not greater than or equal to. So I have to put an open circle, but with my arrow, I'm showing you that -1 could be an answer, 0 could be an answer or a solution, 1, 2, 3, 4, 5, 6, and so on. All of those numbers that are greater than -2 are a solution to this inequality. So there's many, many, many solutions. So from my graph, I'm showing you that. So if I were to graph this inequality, 4 is less than or equal to m. That's actually written in reverse. I would like my variable to come first, so I'm going to rewrite this statement. Rewrite it as m is greater than or equal to 4. The reason that I had to flip the sign is because I'm reading it the way, I'm going to read it from left to right, from right to left to give me my variable on the right. So I have to read it how it's written and then rewrite it the way I said it, if that makes sense. So if I were to reread this and rewrite it, it would be m is greater than or equal to 4. So that's what I rewrote. M is greater than or equal to 4. So now that I've got my inequality written the correct way, or the way that is most helpful to us, I'm going to now identify, am I going to use an open circle or a closed circle? Well, because it has that extra equal to part, I'm going to make sure I have a closed circle. On what number? Well, the number 4. That means all my solutions are greater than 4 and will also include the number 4. So on my number line, I've written some more numbers out. Sometimes you will be given all the numbers on your number line. Sometimes you will have to draw your own number line. So I just wrote a number line in that would make most sense in this problem. And I drew a closed circle on 4, and I'm shading all the solutions that are greater than 4. In this example, again, I'm going to do it with you. So we've got 2 is greater than p. I need to rewrite that. So I'm going to rewrite it. P is less than 2. If 2 is greater than p, then p has to be less than 2. So I'm going to have an open circle on the number 2. So that means all of my solutions are actually going to be less than 2. So on my number line, I go to the number 2, and I'm going to put an open circle, and I'm going to shade or draw an arrow for all the solutions that are less than 2. What if I give you the graph and you have to write the inequality for that graph? Well, it's like what we just did in reverse. So we take a look at our graph, and we need to think about what's happening. Well, in this graph, 6 is a solution. And all the numbers that are less than 6 will also be solutions. So to write my answer, I can use any variable. I can use x or m. I could use s or e. Those are awesome letters. So in this case, I'll just use an x to represent my variable. And 6 is the solution, and I'm shading all the solutions less than 6. So I'm going to say x is less than or equal to 6. That's the inequality that represents this graph. What about my next one? Well, my graph is counting by 2's, so I need to figure out what number comes in between -2 and -4. -3 comes directly in between -2 and -4, so that's where the number that I'm starting with is on -3. -3 is not a solution because it's an open circle. And we're shading all the numbers less than -3. So I'm going to start, I'll do an M this time. M is going to be just less than -3. So there's no equal to portion in that one. Number 3, again, my open circle is on a number in between, directly in between the numbers 0 and 2. What number would that be? Well, that's going to be the number 1. 1 is not a solution, but all numbers greater than 1 are solutions. So I'll use an S this time, and I have a greater than 1. So any solution greater than 1 is what's being represented here in this inequality. And number 4. -4 is a solution, and all the numbers greater than 4 are solutions. So I'm going to use an E, and we're going to do greater than or equal to -4. That would be the inequality for this graph.